All right, let's just jump right in. Today, we're decoding a true behemoth, the Jagannath Temple in Puri. We're talking about a 214-foot tall 12th century marvel. Now, people usually look at ancient monuments and just, marvel at their artistic beauty. But today, we're looking at the hard science. We are going to decode the absolutely incredible physics and engineering secrets hidden right in plain sight.
So here's the thing. From a professional civil engineer's perspective, this building literally shouldn't be standing. It really should have crumbled centuries ago. We're talking about a massive structure built by King Anatavarman using Kalinga architecture that somehow survives earthquakes, totally defies the wind, and actually silences the roaring ocean. Like, no way, right? How on earth did they pull this off without modern technology?
Section 1. The Foundations of Sand. Built on shifting grounds.
We're starting our journey underground, and honestly, this seems completely counterintuitive. Why would you build a massively heavy stone monument on a sandy beach? Especially in an area where seismic activity is a very real threat. Think about current building techniques. Modern engineers would dig way down to solid bedrock and pour massive reinforced concrete footings to stabilize something this heavy. But these 12th century builders, they took a totally different, incredibly innovative approach. So get this, the engineers dug a massive pit and filled the entire thing with just sand. To use a simple analogy, it's kind of like dropping a heavy bowling ball onto a really thick foam mattress. The sand acts as this giant seismic dampener. When an earthquake hits, that loose sand absorbs and totally diffuses the vibrations, so the shock waves never actually reach the main building. Plus, the sandbox provides perfect water drainage, meaning the soil won't liquefy and the foundation never sinks. That right there is the secret to its unbelievable long-term durability.
Moving on to Section 2. Interlocking stones without cement. Kalinga dry masonry. So as we look up from the foundation to these towering 214-foot walls, we get a crazy side-by-side comparison with modern construction. Amazingly, these walls were built entirely without a single drop of cement or lime. While we heavily rely on mortar and cement today, these ancient builders leaned totally on sheer weight and physics. It's called dry masonry. The heavy stones are held securely just by gravity. To bridge the connections, they used iron clamps, and then, this is wild, they poured cooling molten lead directly into the joints. As that lead cooled and expanded, it fused the whole thing together into a practically indestructible structure.
Next up, Section 3. Walls that silence the oceans. The Lion Gate Mystery. Let's take a walk over to the outer walls of the temple, the Meghanatha Pottery. These walls are 20 feet high, 6 feet thick, and they create a truly bizarre auditory phenomenon. The contrast is immediate. When you're standing just outside the Lion Gate, the Singadwara, you hear the loud, continuous, roaring sound of crashing ocean waves. But the exact second you step foot inside the gates, that roaring ocean completely vanishes. Absolute silence from the outside world. Now, this isn't magic or anything supernatural. It's just a masterful application of acoustic damping. That 6-foot thickness and the specific material composition of the wall purposefully act as extreme sound insulation. It beautifully highlights the spiritual connection between Kalinga architectural precision and sacred engineering. They specifically engineered these walls to block out exterior noise, creating this perfectly serene, undisturbed environment inside for spiritual reflection. Absolutely brilliant. All right, Section 4, the flag defying the wind, the spire's aerodynamics. Look 214 feet straight up at the spire, and we hit arguably the most famous visual mystery of the entire temple. I mean, we've all seen flags blow at the wind, right? So seeing one actively rebel against it feels like a glitch in reality. If the wind is blowing hard from the east, the flag at the very top is fluttering vigorously toward the east. How is that physically possible? Well, if we're doing a quick summary for architecture students here, form dictates flow. The fluid dynamics at play are just incredible. When the wind hits that uniquely curved racodula spire, a phenomenon called boundary layer separation occurs. This creates a low-pressure wake region directly behind the temple. And to fill that low-pressure gap, the wind actually flows backward, creating vortexes or eddies. So the curved spire literally forces the wind to separate and flow in reverse right into that pocket, dragging the flag backward with it. Which brings us to Section 5, the 8-metal lightning arrestor, the Nila Chakra.
While we're looking up at the spire, we definitely have to talk about its crown jewel sitting right at the peak. The Nila Chakra is made of Ashtidahu, that's an alloy of 8 different metals, and the whole thing weighs a staggering 8 tons.
Honestly, just getting an 8-ton metallic disc 214 feet into the air without modern hydraulic cranes, relying entirely on ancient ramp principles, that is a mind-blowing logistical feat all on its own.
But its primary function is actually protective. The Nila Chakra acts as a massive lightning arrestor. It's directly connected to metal strips that run all the way down the height of the temple and deep into the ground. So when a coastal storm rolls in, it catches those lightning strikes and safely guides millions of volts right into the earth. That perfectly protects the dry masonry stone structure from literally being blown apart. And as a really brilliant bonus, the designers engineered it with perfect spherical symmetry. This creates a super fascinating optical illusion for anyone looking up from the ground. Seriously, no matter where you stand in the city of Puri, no matter what angle you look from, the Nila Chakra always appears to be facing you directly. It's such a cool detail.
Finally, Section 6, Thermodynamics in the Kitchen, the multi-pot cooking system.
All right, let's step out of the weather and into the temple kitchen, where physics continues to run the show. Now, you'd naturally assume the pot closest to the fire finishes cooking first, right? I mean, that's just basic common sense. But the Jagannath Temple kitchen flips that logic entirely upside down. Out of 9 stacked pots, the one at the very top is actually the one that is fully cooked first.
Here is the masterclass in heat convection at play. 9 clay pots are stacked vertically right over a wood fire. As the food in the bottom heats up, the rising steam naturally acts like a vertical pipe. It travels upward until it gets trapped entirely in the uppermost pot. Because the steam is trapped there, it drastically spikes the temperature and pressure in that top container. By utilizing this process, the uppermost pot actually finishes cooking before the ones right above the fire.
So, when you step back and look at the whole picture, the sandbox foundations diffusing earthquakes, the acoustic damping of those massive outer walls, the fluid dynamics manipulating the wind, the advanced metallurgy of the lightning system, and the thermodynamics of the kitchen, it is abundantly clear. This is a masterclass in varied scientific disciplines. It's exactly like the quote says. This is proof of ancient India's most advanced engineering.
I'll leave you with this thought to ponder today. We just spent this time decoding the physics of a single temple built over 8 centuries ago. How many other ancient architectural miracles around the world are actually just incredibly advanced engineering, waiting patiently for us to finally decode them?